So first we're looking at even, odd, or neither. The rule for even and odd is that when you plug in a negative x, you see what happens with it. If the negative kind of just disappears, and you just get f of x. That's an even function. If when you plug in the negative, you get a negative times the entire function, that's an odd function. So when we plug a negative in here, you get 6 negative x to the 5 halves. You have to look at the entire exponent. So that 5 over 2, you could rewrite that as 6 to the 6 times the square root of negative x to the 5th power. We have square root of negative x. The 5th power is going to keep that as a negative, even if you did like the 5th power first. It's going to keep it as a negative. So you have a negative inside a square root, which is going to be an imaginary. You can't do that. You can't have a negative inside the square root. So therefore, it will be neither. It just breaks the function. You can't have negative inside. Similar question. We're going to do the same thing. So 6 negative x to the 6/7. That's a 7th root of negative x to the 6th. If you do that 6th exponent first, you have negative times negative times negative times negative times negative times negative. Since it's an even exponent, that's going to turn it. It's going to cancel out the negatives because it's an even exponent. And when we compare this to the original, that's the exact same thing we started with. So referring back to what we wrote before, when you plug in a negative and you get the exact same thing we started with, that's an even function. So this asks a whole bunch of them. So the shortcut for polynomial functions like a is you can just look at the exponents. The exponents on the variable. So on a, we have an exponent of 4 and an exponent of 1. 4 is even, 1 is odd. That's a mixture, so it's neither. Which means it's definitely not even. B, we have an exponent of 4, and then the exponent on the variable there would be 0. That would be like 3x to the 0 power. 4 is even, 0 is even. That means that's an even function. If all the exponents are even, it's even. We're going to skip over C for a moment just to stick with the polynomials. We have an exponent of 3, an exponent of 1, and then again, this is an exponent of 0. Odd, odd, even. So neither. G, same thing. We have an exponent of 3 and an exponent of 1. 3 is odd, 1 is odd, so that's an odd function. So it's not even. Then we have some parent functions here. Natural log of x looks like that. When you have the graph, if it has symmetry over the y-axis, it's even. If it has rotational symmetry, it's odd. Y-axis is even. Rotational symmetry, or origin axis, or origin symmetry, not axis, then it's an odd function. So natural log looks like this. That has no symmetry. It doesn't have rotational, also does not have y-axis, so it's neither. Sine of x kind of looks like that. Passes through 0, 0. Whoops, I drew that backwards though. Passes through 0, 0, kind of like that. If you rotate that, that works out. So that means sine is odd. That has rotational symmetry, not even. E to the x, like a ramp. There's no symmetry on that, so that's neither. Cosine. Cosine kind of looks like that. If you fold it over the y-axis, it matches up. So that's got y-axis symmetry, so it is even. Cosine's even, sine is odd. Natural log and e are neither. So apply that onto the next one. Cosine's even, sine is odd. Cosine's even, sine is odd. Natural log and e are neither, just like we just talked about. Now we just have to do the polynomials. We're checking the exponents. We've got a 3, a 1, and a 0. That's a mixture, so it's neither. On B, we check the exponents. We got a 3 and a 1. Those are both odd, so that's odd. On F, we got an 8 and a 1, even and odd, so it's neither. And then G, we have an 8, and then that's x to the 0. 8 and 0, those are both even. So it's even, not odd. For the difference quotient, you just do what it says. When it says f of x minus 4, that means you're plugging x minus 4 into the equation. So that's 4 times x minus 4 squared minus 1. And then we do the minus f of 4, so minus, plug in 4. That's 4 times 4 squared minus 1. All over x. Now it's just a whole bunch of algebra, including multiplying out x minus 4 squared. And let's see, 4 times 4 squared, that's 16 times 4 is 64. Minus 1 is 63. Now we have to distribute that 4 into those parentheses. (32x) plus 64. Then we have a negative 1 and a negative 63. That's minus 64. Plus 64 and minus 64, those cancel out. And we're left with two terms that both have x in the numerator, so factor out the x so that we can cancel. Don't worry about taking anything else out because we just want to cancel the x's. So you're left with 4x minus 32. Just remember, since there was an x in the denominator, you have to say x is not allowed to be 0. That's it. Ignore the spelling typo. But which of the following represents a cubic polynomial whose zeros include 4 and 3 plus 1i? So what we know about complex roots, complex zeros, they always happen with their conjugate. So if we've got 3 plus I, we also have 3 minus I. They're always going to happen with the conjugate. So if we write that out, if 4 is a 0, that means x minus 4 is a factor. 3 plus I is a 0, that means x minus 3 plus I is a factor. And then same thing with the other one, x minus 3 minus I. We want to get rid of these extra parentheses, so distribute this negative on both of these. And now we need to multiply together. So what I showed you guys in class was that if you group these x minus 3s, that doesn't change any of the algebra. You would still do x minus 3 first, no matter how you look at that. But now that that's grouped, you can see that these two parentheses are conjugates of each other. So when you multiply them out, you're getting x minus 3 times x minus 3. So x minus 3 squared. And then since they're conjugates, the next multiplication is going to cancel out until you get to just the negative I times the positive I, which would be negative I squared. So x minus 3 squared, that's easy to multiply. X squared minus 6x plus 9. I squared is negative 1, so that's minus negative 1 means plus 1. So we put these together to get 10. And now we're going to multiply the x minus 4 to x squared minus 6x plus 10. And combine your like terms. So there's your polynomial. You could say f of x equals or whatever, but that's your polynomial. Partial fraction decomposition. So as you start these, first ignore that that's just written weird with a minus and negative. You can just think of that as plus. With partial fraction decomposition, the first thing is that you're going to factor the denominator. So we're going to factor the denominator. And that is 8 and 5. So one of our denominators is x minus 8. The other one is x plus 5. You put an a on top. You put a b on top. Now we want to clear out fractions. So we're going to multiply everything by the common denominator. So that's canceled. The x minus 8 will cancel, and this just needs to be multiplied by x plus 5, which will remain. And then vice versa over here. X plus 5 is going to cancel, and this will get multiplied by x minus 8. We've got 4x plus 7 equals a times x plus 5 plus b times x minus 8. And then the trick to solving these out is we're going to be clever. We're going to pick an x value to plug in. That's going to cancel out either a or b. So if we cancel out the a, the x value that we would choose would be negative 5. x equals negative 5. So if x is negative 5, you get negative 20 plus 7 equals a times 0, and then b times negative 13. So negative 13b equals negative 13. So b is 1. And then to cancel out the b, the other x value we're going to choose is 8. If you plug in an 8, that makes a 0 to cancel out the b. 4 times 8 is 32. Eight plus 5 is 13, so 13a, and then the b times 0 cancels out. So 39 equals 13a. A is 3. So to write your final answer here, you put the 3 on top of the x minus 8, since that's where a was. And then b goes on top of x plus 5. And that was positive, so it's plus. There's your partial fraction decomposition. The directions on this one are a little bit messed up. It says which graph below. There's no graphs. So instead, we're just going to go through. We're going to get vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, so that way we know the graph. So vertical asymptotes, you get from the denominator equals 0, x equals negative 4. Horizontal asymptotes you get by looking at the coefficients. So you have 1x squared over 1x squared. So that's y equals 1 over 1 is 1. X-intercepts you get from the numerator equals 0. So you factor that out. You'd get x times x plus 8. So x-intercepts, you get x equals 0 and x equals negative 8. Or you could say 0, 0, and negative 8, 0. And then y-intercepts, you just plug in 0. When you plug in 0, you get 0 over 16. So our y-intercept, y equals 0 over 16, which is 0. Or you can say the coordinate 0, 0. If you know x-intercepts, y-intercepts, and horizontal asymptotes, you can pick the graph from the options if they give you options.